This is Anita Wood, and welcome to this topic snippet video introducing a tool that we're going to use that will help develop our logic. It's called the IPO chart. Let's start with a review from the previous video. This graphic shows the basic logical structure that all types of computers follow. A computer is an electronic data processing device, which A, accepts data input, B, stores data input and processes that data, and C, generates the output in a required format. We're going to carry this concept of a computer to introduce a diagram that software designers use to describe the processing of information, an input processing output, or IPO chart. These are used to assist in the creation of complex software. They're frequently used during the first step in the programming process. While we're talking about the programming process, let's take a quick review of all the steps. Once we have a good understanding of the problem, which the IPO chart is going to help us with, we start planning the logic for the solution. We use the logic to code our program and generate executable code or machine language. We know from last time our job is not complete until we have fully tested the program using the test data we created while we developed the logic. A fully tested program is put into production, and once in production, we enter the maintenance phase. In the maintenance phase, we handle any changes that the users ask for. So back to the task at hand. The use of IPO charts to help us better understand the problem. Now, a simple table is a typical way to create the IPO chart with the headings of the columns corresponding to the three areas we wish to capture. We will write the description of each component in plain English, not code or mathematical formula. Here are the 5 steps that you should follow to complete the IPO chart. The first is in the first column called input. You write anything that is needed from the user or the person using the algorithm. In the output, we write the end result that was stated in the problem. So now we have the beginning and the end figured out, and all that's left is the processing. So in the processing column, write get. That's actually the word, and anything that's in the input column, okay? And if there's nothing in the input, skip this step, because what we have to remember to do is we have to move the stuff that the input device is giving us into the area so it can be processed. So that's where the get comes from. Now, once we have everything in, we want to answer the following question. What do I have to do with the inputs in order to produce the desired outputs? So write down in the processing column whatever should be done. And you follow up with a display, the word display, anything that's in the output column. Because remember again, we're in a processing world and we have to make sure that we move anything that needs to be displayed to the user out. So we write display. Let's take a simple example and use these steps to complete the table. The program is required to read 3 numbers, calculate, and print their totals. Seems simple. So let's get started. The first step is completing the input column. The person using the algorithm or user has 3 numbers we need from them. So 3 numbers is written in the input column. Okay, you can use anything you want there. This just happens to be what I'm using. You could actually even have num1, num2, num3. Next, we complete the output column. The problem asks us to print or output the total. So that's what goes in this output column. We're going to use total here, but sum would work just as well. Once we make the decision like that, though, the important thing is to not the name that we use, it's that we use the same name every time. Consistency is going to really count throughout this programming process. Now, we have to get the input from the system for the processing. We use the word get to signal moving the data from the input component into the processing unit. Using the directions, we complete the get step. And I just said get 3 numbers. You could again say get num1, get num2, get num3. Both are acceptable. The next step is to complete the processing column. We answer these questions here. What do I have to do with the inputs in order to produce the outputs? So we need to write down what needs to be done to produce the total, which is denoted here as calculate the total. Simple enough. No, we're not getting into the specifics of how the calculation must occur, just that we just know it has to occur. So there really isn't any more processing necessary. So the final step in the entire process is to have the processing display what is the output. In our simple example, that means we display total. We can utilize Microsoft Word to create IPO charts. Pretty simple. If you're going to try Word, make sure that you understand the workings with tables, because that's the easiest way to design the IPO charts in Word. You insert a table and you start with a 3-column by 2-row. Make sure you add the appropriate headings of input, processing, and output. I'd like you to practice developing an IPO chart. We went through it pretty quickly. I have the answer on the next slide, but I hope that you would attempt this activity on your own. So stop the video and come back with your answer. Here's my IPO for the problem. I'm sure yours is very similar to the ones displayed here. Remember that the words you use to reference the input and the output of the data is not critical here. What is that you use them consistently. So our problem was to write a program that read 2 numbers, and then the program's going to calculate and print the sum, the average, and the product. Like before, I just inputted 2 numbers, or you could have done number 1, number 2. I get them, I calculate the total, I calculate the average, I calculate the product, I display total, display average, display product, because that's what I placed in the output, and that's what the problem was looking for me to do. These are pretty simplistic problems, the 2 that I showed you. And it may seem like this is a needless step for understanding the project and problem in general, but as the problem gets more detailed, these charts really do help you keep track of what's necessary to keep this thing going and eventually reach the processing, which is the programming part. So there is an assignment in Blackboard, Module 1, Topic 1, where you're going to create a simple IPO chart. And I have the confidence that you won't have any issues completing this assignment. That concludes this topic snippet video on the IPO chart.